Hi there and welcome to this example lesson of electrochemistry. We're looking specifically at electrolysis of copper sulfate. Okay, so in the previous video we gave you a brief introduction to electrolysis, and what we said is we would have a single container, and in our container we will have a solution. Now I'm not going to color the solution because it was a little bit difficult to see what we're doing. But here we will have a electrolytic solution, and specifically if we're talking about the electrolysis of copper sulfate, here we would have copper sulfate solution. Copper sulfate we know has a 2 negative charge, and so copper must have a 2 plus charge. Copper can have 2 plus, 1 plus, 3 plus, but this specific copper has 2 plus, and then sulfate will have SO4. Okay, 2 negative. Then what we would have is we would have 2 electrodes. So we'll have our electrode, and connected on the outside circuit we will have a power source, and that's what makes the difference between an electrolytic cell and a galvanic cell. And a galvanic cell has a electrolysis solution, two chemical reactions producing a current, while in an electrolytic cell we have a electric current producing two non-spontaneous reactions. In other words, reactions that would not occur unless we introduce energy into the system. Okay, so what is going to happen here? Okay, so here it's important for the electrolysis of copper that my two electrodes be made of copper themselves. So these are copper electrodes. Okay, and so what is going to happen? So electrons are going to flow in this direction. This is the flow of electrons, which means that this will become negatively charged as it receives electrons from the cell or the battery. Then as it has electrons, the positive coppers will be attracted to the negative charges, and so copper will tend to go towards the copper and receive electrons. So we will have this this would happen at the cathode. We say the cathode is the one receiving electrons from in the outside of the circuit. So we will have copper 2 plus will get 2 electrons from the electrode to produce copper solid. And now I actually used the wrong color here, but let's say copper was now yellow. So what we will find is we will have a plating, copper plating, starting to happen on the cathode here. Now, which means since this copper here, or this electrode, the cathode electrode, was giving electrons, it didn't itself had to be made of copper, but it will be plated with copper. Okay, so for example, if I wanted to plate a spoon with copper, a metal spoon, I could let a current pass into a copper sulfate solution and it will produce a plating. On the other side, however, now we get this electrolytic solution becoming negatively charged because it's receiving electrons. Okay, so it's becoming negatively charged. So now we need, on the other side, electrons to be taken out of this solution, and we need positive charges to be introduced into it, okay, or at the same time. So what happens on this side is that copper solid starts giving away, so this copper electrode here starts giving away copper ions into the solution, and it gives that away because electrons are being pulled away from copper. So the copper solid, literally now the electron is taking part in this reaction, because the copper solid is now losing 2 electrons and then releasing into the solution copper 2+ ions, and this will continue to happen. Okay, sulfate is a spectator ion. It only allows the current to pass through in the solution. So, but what will happen to the anode? Remember, the anode is the electrode from where electrons flow in the outside circuit. So the anode, which is made of copper, this time it has to be made of copper so that we can keep the concentration of copper in the electrolytic solution constant. But what will happen to this electrode bar? This electrode bar will start to erode. Why? Because we're losing copper solids. Copper solids is becoming copper ions. Copper ions are now being donated into the solution. So this is eroded and this is plated. Okay, this is very simple, don't you think? Okay, there's not much more I can say about this other than electrochemistry, and especially electrolysis, is really simple. So thank you very much for watching. We'll see you in the next video where I will look at the electrolysis of water, H2O. See you there.